Hello! For today, I have another trigonometric problem. If we have the function defined by sinus of x minus 1 over 2 sinus of 2x plus 1 over 3 sinus of 3x, we have to show that sinus of 3x is equal to sinus of x bracket 4 cosinus squared of x minus 1. And that if x is between 0 and pi, there are no such values of x for which f is 0. Please check A by yourself. The hint is that we can write sinus of 3x as sinus of 2x plus x. Considering that we have demonstrated A, let's see what happens at B. We will rewrite f substituting sinus of 2x and sinus of 3x as we know and as we found out. F is sinus of x plus minus 1 over 2 or times 2 sinus of x cosinus of x, which is the formula for sinus of double angle, plus 1 over 3 sinus of 3x. We will use the result from A. This means times sinus of x bracket 4 cosinus squared of x minus 1. We have in this expression 3 terms, 1, 2, 3. We can see there is a common factor, which is sinus of x. So we'll write sinus of x before a bracket. And in the bracket, we will get 1 from the first term minus cosinus of x from the second, because 2 will be cancelled with 2, plus 1 over 3 bracket 4 cosinus squared of x minus 1. We will expand the small bracket inside the bigger one. So f is sinus of x bracket 1 minus cosinus of x plus 4 over 3 cosinus squared of x minus 1 over 3, which is, when rearranging the terms inside the bracket, sinus of x bracket 4 over 3 cosinus squared of x minus cosinus of x plus 2 over 3. In this moment, we can do the analyze. So, f equals to 0 will mean that one of the factors of f should be 0. We will have or sinus of x equals 0, which for x between 0 and pi can never happen. Let's remind how the function sinus of x looks like. Between 0 and pi, sinus of x looks like this. Because x is between 0 and pi without being 0 or pi, we can see function is always positive, so no zeros. So for x greater than 0 and smaller than pi, sinus of x is always positive, so it won't be 0. Let's analyze further what happens in the bracket. So we can also have 4 over 3 cosinus squared of x minus cosinus of x plus 2 over 3 should be 0. We can look at this equation as a quadratic equation by substituting cosinus of x with y. This means that we will have the equation, the quadratic equation, 4 over 3 y squared minus y plus 2 over 3 equals 0. It's easier not to work with fractions, so we can multiply this equation by 3. We will get 4y squared minus 3y plus 2 equals 0. Let's check how the discriminant for this equation looks like. You will know formula for discriminant of a quadratic, which is minus 3 squared minus 4 times 4 times 2. You can check the formula for the discriminant of a quadratic equation. This is 9 minus 32, which is a negative number. Because the discriminant is a negative number, we know this equation won't have a real root, which means 4 over 3 cosinus squared of x minus cosinus of x plus 2 over 3 can never be 0. So we proved that for x between 0 and pi, f cannot be 0, which was to be shown. Goodbye.